Good morning.
Good morning, sir.
Any doubt from last class, Fatima?
No, sir.
Okay, tell me the last topic, what we did. Thermal kinetic energy, I think.
We did a question if 4 grams of hydrogen gases at
Okay. That was internal energy. Okay. Now there will be question, if you have mixture of non-reacting gas, then how will you calculate Cp, Cv and gamma? For on mixing non-reacting gas, number of moles on mixing based on conservation of matter will be simply sum of number of moles of individual gas. Cv of mixture will be N1 Cv1 plus N2 Cv2 divided by N1 plus N2. Similarly, Cp of mixture will be N1 Cp1 plus N2 Cp2 divided by N1 plus N2. Now, if you divide these two terms, so gamma of mixture will be Cp of mixture divided by Cv of mixture. Let me give you a question related to this part. You will be asked if 1 mole of oxygen and 2 mole of helium is in a vessel. Find gamma of mixture. So according to above concept, we can say first we have oxygen. Number of mole of it is 1. So N1 is 1 and second is helium. So N2 is 2. So oxygen is monoatomic or diatomic? Fatma, tell me about oxygen. Is it monoatomic or diatomic?
Monoatomic.
Oxygen exists as gas or molecule as H2. Helium, inert gas, exists as only He. So oxygen will be diatomic and helium monoatomic. Is it clear?
Yes, sir.
Next, degree of freedom for diatomic will be 5 and degree of freedom for monoatomic will be 3. According to formula, Cv is equals to F by 2 times of R and Cp is equals to 1 plus F by 2 times R. So if you substitute Cv1, it will be F by 2 times of R, that will be 5 by 2 times of R, and Cp1, 1 plus F by 2, so it will be 7 by 2 times of R. Similarly, Cv2 is F by 2 times of R, so it will be 3 by 2 R, and Cp2, 5 by 2 times of R. Now just substitute these values in the above formula, you'll get gamma of mixture. Is it clear?
Yes, sir.
Just write it down and try to simplify it. Am I done?
Yes, sir.
You got any answer for this gamma of mixture on solving this? Let me simplify it. According to the formula, gamma of mixture is N1 CP1. N1 is 1 and CP1 is 7 by 2 times R. N2 is 2 and CP2 is 5 by 2 times of R. Divide by N1 CV1 5 by 2 times of R, N2 CV2 3 by 2 times of R. Is it clear?
Yes, sir.
Now take out R by 2 as common from numerator. So you'll get 7 plus 2 into 5. Divide by, from denominator also, take out R by 2 as common. So you'll get 1 into 5 plus 2 into 3. So this part and this part will cancel out. 2 into 5, 10 plus 7, 17. Divide by 1 into 5, 5. And 2 into 3, 6 plus 5, 11. So it will be our gamma of mixture. Is it clear?
Yes, sir.
Next, we have to calculate velocity of gas. In general, we have three different velocity of gas. First is average velocity. V average equals to V1 plus V2 and so on if we have a number of gases particle. Let me define you. Suppose you have any tabular form in which this is velocity of gas and this is corresponding number of particle moving with that velocity. Let's say V1 velocity having F1 number of particle, V2 velocity having F2 number of particle, and so on, Vn number of velocity or Vn velocity having Fn number of particle. So if you have to calculate average of all these terms, so it will be summation Fi Vi divided by summation Fi, like sum of observation divided by number of observation. So from this tabular form, you'll get average velocity from this relation. But in terms of whole volume, average velocity is equals to 8 by pi times r into t divided by m root under, which may be also 8 by pi in terms of kb by m. In terms of pressure, it will be 8 by pi p by rho. You may use these different formula according to the given question. This is for whole volume. If you have given whole volume of gas having temperature, mass, molar mass, or pressure or density according to this. Next, most probable speed, which is VMP. The velocity with which most of the gaseous particles are moving with are called most probable speed. The velocity with which most gaseous particle moving with is called most probable speed. In terms of whole volume, VMP is equals to 2 times of RT divided by M root under 2 times of KBT divided by M root under, or simply 2 times P by rho root under. Fatima, any doubt?
No, sir.
Similarly, one more thing, how to calculate root mean square velocity, that is VRMS. So it will be summation of Fi Vi on squaring divided by summation Fi. That is sum of observation while taking the square. So it will define you mean square velocity. Now, if you take a root of this whole term, this will give you root mean square velocity. In terms of whole volume, VRMS is equals to 3 times of RT by M root under, which is equals to 3 times KBT by small m root under, or which is also equals to 3 times P by rho root under. We may calculate this particular relation according to pressure, as we have pressure equals to 1 by 3 rho V square. So we may write V square equals to 3 times P by rho. Now taking square root to both sides, this expression is called VRMS. Is it clear?
Yes, sir.
Now from this relation, you'll be asked only one thing. Arrange these different velocity in ascending order or descending order. So how to learn this particular relation between these three different velocity? Just remember RAM. First word is R, it means RMS velocity. Second word is A, it means average velocity. And third word is M, most probable speed. So this will be maximum, then this and this. So this is the relation between these different velocity of gas. Any doubt?
No, sir.
Just write it down.
Done, sir.
Now, the last part of this chapter is mean free path. Suppose there is a gaseous particle, this. It moves along this direction to collide with this gaseous particle and get deflected along this direction. Further, there will be some other particle like this. So it may collide with this one and get deflected along this direction. Further collision, get deflected along this direction, and so on. So we may define for these different collision some term. First is, let's say distance traveled by this first particle. I'm considering this one is moving, rest of the whole term is at constant rest. So it will cover x1 amount of distance to collide with this particle. Similarly, x2 distance to collide with this one, x3 amount of distance to collide with this one, and so on. So x1, x2, x3, these are distance gap between any two successive collision. So if you take average of these all distances, that is called mean free path. Is it clear?
Yes, sir.
So mean free path is nothing but the average distance gap between successive collision. So it is denoted by lambda, which is equals to x1 plus x2 and so on to xn, divide by number of collision n. Now in this part, we may define some more term. First, next is, suppose this particle on moving from this point to this point takes t1 time for first collision, t2 time for second collision, t3 time for third collision, and so on. So the average of time gap between any two successive collision, we may define it as relaxation time, average time, or simply relaxation time, denoted by tau, or sometimes t average. So this is the average time gap between successive collision between gaseous particle. So tau equals to T1 plus T2 plus so on to Tn, divide by number of collision n. And one more thing, let's say this particle on collision will have some velocity v1, at this point v2, at this point v3, and so on. So if you take average of these all speed, that is called average velocity or average speed. So next is average velocity. The average of all speed in between successive collision. So it will be V1 plus V2 and so on to Vn, divide by number of collision n. Fatima, any doubt?
No, sir.
Just write it down. Fatima, done?
Yes, sir.
Okay. Now we have to calculate mean free path related to this entire term. So how to calculate mean free path? Suppose this is one of the gaseous particle we are assuming which is in motion. The rest of the term will be in constant. So within its range, it may collide with other gaseous particle. Let's say this is at this point. Some other gaseous particle is at this point. I'm assuming this one is moving and so the whole term is at constant. Consider this particular term as a cylindrical vessel. So total distance from one end to other end will be speed into total time taken, that is this. I'm assuming diameter of each gaseous particle is d. So distance of this point to this will be also d. So it will act as a radius of this cylindrical column. Consider an gaseous particle having diameter d and number density small n, in which only one of the particle is moving and rest of the whole term is at constant. Only one particle is moving. So first we define number density. Number density is simply number of gaseous particle divided by volume. I'm assuming just this particle is moving and rest of the whole term is at constant. So for each particle, it will collide. So number of collision will be equals to number of particle in it. So this will be also equals to number of collision. Fatima, is it clear? Why number of particle equals to number of collision?
Yes, sir.
I'm considering just this particle is moving and rest of the whole particle is at rest. So it may collide each particle one at a time. So the number of collision must equals to number of particle. Now, volume of this particular cylindrical segment will be pi r squared times height, where height is average velocity times delta t. Now, from this part, we calculate number of collision will be number density multiplied by volume pi d squared times average velocity times delta t. Now move this delta t to left side. So you'll get number of particle divided by time taken. equals to n pi d squared times average speed. So this is called number of particle or number of collision per unit time, which is also called rate of collision. Or collision per unit time. So if you take a reciprocal of it, that is delta t divided by n. So it will become 1 by n pi d squared times average speed. So this quantity is called average time or relaxation time. Average time gap between successive collision. Any doubt?
No, sir.
Just write it down. Fatma done?
1 minute. Done, sir.
Now from this last part, let me define you. So mean free path is equals to average velocity multiplied by average time gap between successive collision. So mean free path is denoted by lambda. Average speed is this, and relaxation time or average time gap we have calculated in left part. If you substitute, you will get 1 by n pi d squared times average speed. So this part and this part will cancel out. So we'll get lambda equals to 1 by n pi d squared. But this expression, but there is some mistake in this particular part. Just 1 minute. Okay, in this derivation, we have assumed only one gaseous particle is moving and thus the whole volume is at rest. But it will be not possible since in a particular volume, all gaseous particles must be in motion with respect to one another. So it will be better to take average of relative velocity between each gaseous particle to derive this particular result. So we can transform this particular relation and we can say, since all gaseous particles must be in motion relative to one another. So it will be better to take average of relative velocity. So using this concept, mean free path now becomes root under 2 n pi d squared. So this is your final expression of mean free path. Is it clear?
Yes, sir.
Now we have to transform this particular formula to define its various affecting factor. First, density is equals to total mass by total volume. So we may write total mass as number of particles, mass of each gaseous particle divided by volume. N by V is also called number density times M. So number density is equals to density of gaseous particle divided by mass of each particle. So if you substitute in this formula, lambda will equals to m by root under 2. In place of n, it will be rho. So n pi d square rho. This would be first formula of mean free path. So from this, we can say mean free path is directly proportional to mass of gaseous particle, inversely proportional to density, and inversely proportional to square of diameter of each gaseous particle. We may further transform this particular relation in some other form as well. Suppose for 1 mole of gas, PV is equals to nRT, so it will be just R into T. Now just divide each side by N and N. So in this part, if you take a reciprocal, N by V becomes P times N divided by R into T. This is called number density. This particular quantity is called Boltzmann constant. So we may write it as pressure divided by Boltzmann constant times T. So if you substitute in this formula, you'll get another expression of mean free path. So it will be lambda equals to kBT divided by root under 2 times pressure pi d square times P. So we have mainly 3 different relations for this mean free path. Just remember this part and then these 2 terms also. Any doubt?
No, sir.
Just write it down.
Done, sir.
So this is all about this entire chapter, kinetic theory of gas. So from this entire chapter, you'll be asked 2 derivation. Either you'll be asked pressure exerted by gas, first one, or this derivation, that is mean free path. Next question will be related to definition of law of equipartition of energy, and degree of freedom and calculation of it. That's it. Okay.
Okay, sir.
Now, let's start with new chapter, that is simple harmonic motion or oscillation. In this part, first, what do you mean by periodic motion? Any idea what do you mean by periodic motion? Suppose this is nucleus of an atom. An electron is revolving around it in circular orbit like this. Similarly, motion of planet around the sun, motion of heavenly body around any planet, motion of satellite, and so on. For all these different motion, its time period on complete rotation will be fixed. Is it clear?
Yes, sir.
So we can say periodic motion is the motion of a body having fixed time period is called periodic motion. Like motion of planet around the sun, motion of satellite around planet, motion of electron around nucleus, and so on. All are periodic motion. Let me define you one more periodic. Suppose if you have a pendulum or a bob attached to any string which is oscillating to and fro about this given position. There is a bob which is oscillating to and fro. So this is also a periodic motion. But there is a speciality between these two periodic motion. In this part, if this electron, let's say this is starting point. So on complete rotation, it will comes back to its starting point. But in this part, this is one end and this is other end. And this is mean position. This is extreme and this is also extreme. So we can say in this part, this bob is oscillating to and fro about this given mean position. So in a periodic motion, if it is about a given fixed position, that is mean position, then this periodic motion is also called SHM or simple harmonic motion. Is it clear?
Yes, sir.
So we can say a periodic motion in which body moves up and down or to and fro about a given fixed position called mean position, then this motion is called simple harmonic motion, or simply SHM. Is it clear?
Yes, sir.
So from this we can say simple harmonic motion is special type of periodic motion. So all SHMs are periodic, but all periodic are not SHMs. Just write it down.
Done, sir.
Now to define this SHM, let me give you an example of uniform circular motion. So next is uniform circular motion as simple harmonic motion. Suppose at any instant there is a particle at this point which is going around the circular path. So at some instant it will be at this point, this, a particle is going along this way. Along the circular path at constant angular velocity omega. So if you drop projection of this particular particle or shadow of this particular particle along x-axis, let's say this projection will be at this point. If you follow this particular part, it will be at origin, this point, this point, It means particle initially at this point, which is going along this way, further return back, we reach finally at this point. Now, if you just consider in this part, motion of projection of body along x-axis, only this part, you'll observe this motion is to and fro, to and fro, to and fro about this given position, that is mean position. Is it clear?
Yes, sir.
Similarly, if I have to take its vertical projection, that is projection along y-axis, so if you draw its vertical projection along y-axis, at some instant will be at this point. It means if the particle starts from this, going along this way, so motion of projection will be then return back to reach at this point and further to reach at this position. So if you take motion of projection in this part along y-axis, so it is behaving motion of particle up and down about this given position origin. So we can say this is also SHM or simple harmonic motion. So from these two parts, we can conclude if a particle is uniform circular motion, so motion of projection along any diametrical axis, that is along x-axis or along y-axis, will act as simple harmonic motion. So in this part, we can say this is motion of projection along x-axis, and this part, this is motion of projection along y-axis. Fatima, any doubt?
No, sir.
So from this, we can conclude during uniform circular motion, the motion of projection of body along any diametrical axis will be simple harmonic motion. Just write it down.
Done, sir.
Now using this concept, let me derive equation of SHM. Consider there is a particle revolving along circular path at constant angular velocity omega. So at time t is equals to 0, it will be at this point. So inclination of this with respect to x-axis is phi. At some later time, it will be at this point. So it may cover this point to this point omega times t, or angle subtended omega times t. So if you draw projection of this particular particle at this point on x-axis and projection of particle along y-axis. So it will be x component from this point to this point, and this will be y component from this point to this point. Consider particle of mass m is along uniform circular motion with velocity omega and radius a. Now, if we take out this particular triangle, total inclination from this point to this point will be theta. So it will be equals to omega t plus phi. This is radius of the circular path. This is y component and this is x component. Fatima, any doubt?
No, sir.
Now from this triangle, if we take sine theta, so it will be perpendicular by hypotenuse. So y will be equals to a times sine theta, and theta we have omega t plus phi. Similarly, if we take cos theta, so it will be base over hypotenuse. So x will be equals to a times cos theta, and theta we have omega t plus phi. These two expressions This one and this one will define you nothing but SHM. Now let me define you corresponding term and what does this mean. So in this part, X and Y simply defines you nothing but displacement of particle at any instant or at any time t. A is maximum displacement, which is called amplitude. Omega is called angular velocity, which is nothing but 2 pi over t, or simply 2 pi into frequency. And the theta, which is equals to omega t plus phi, is called phase. So if you put t is equals to 0, so theta naught will equals to phi. This is called initial phase. Fatima, any doubt?
No, sir.
Okay, just write it down. Are done?
Yes, sir.
Any doubt up to this part?
No, sir.
So let's stop here for today. In next class, I will define you how to solve problems related to these different equations. Okay.
Okay, sir.
Okay then. Thank you.
Bye, sir. Thank you.